Right. From the beginning, just to make sure that we have included everything in the recording. So what we were discussing is the development strategies that the company had in the beginning. The organization can develop the software itself with the help of the IT department or the software developers they had. Or if it is a very general information system, we can look for, maybe already you can purchase the software you already have as a software package. Then you can hire a consultant for the work. And then you can also get some outside resources in case the organization does not have the required expertise. But today's world, or how the information system, the development strategies, we have more options. Now, for example, the first one, we have application service providers, where there are already available service providers are there. And then we have a lot of web apps, web hosted software solutions, where we need only just internet and the browser. And then some companies or some firms say they have their enterprise-wide software solution, where we can, enterprise level software system that we can incorporate. Now, the challenging part would be is how do you select the best one? Now, given you, let's assume that you are the one who's going to make this particular decision. Let's say as a SLTC university, let's say we need a software solution to manage our operations. So what strategy we should select? What development strategy we need to follow? Are we going to develop ourselves internally? Are we going to purchase already available package? Or are we going to have some external consultants? Or are we going to use existing web application? So this is exactly the topic that we are going to discuss today. Sorry. Right. Now, going back to the software solutions available, now with the internet, we have the access to software as a services, which is the cloud-based solutions now we have. So in traditionally, what we had was we had a traditional model where we have vendors, they develop and they sell applications. And usually how the usage of application happens, we have to purchase some licenses. Maybe we have to pay annually, or maybe we can purchase directly the software, right? And it's governed by whatever the agreements. But with the software as a service or SaaS model, and software is hosted as a service, and then we are going to use it over the internet. So what happens ideally in the organization side, we don't need to maintain. Now, early days, we have all the hardware, software, we have technical people to manage everything within the organization. With the cloud computing, so what has happened? You don't need it anymore, right? So what you need is basically, so everything will be on the internet. Right. Now, just to have a brief discussion on software as a service, you can see early days, I told you everything in this organization. On-premise, that means the organization manage everything, starting from applications, data, runtime, middleware, operating systems, virtualization, server, storage, network, everything is in a single place. But now what happens with the cloud computing and the cloud technologies, we can actually have all the infrastructure part managed by a particular vendor. So, for example, we have Microsoft Azure. Um, so they offer you all the information that won't have Google engines, Oracle Cloud. So these are some of the examples where they can have the infrastructure they need through a vendor. And what the organization has to maintain is only the application data, runtime, middleware, and the operating system. Now, then we have platform as a service, which means apart from applications data, all the others managed by uh, the vendors. So in that case, we can say Google Cloud, AWS, again, Oracle Cloud Platform, Red Hat OpenShift. These are some of the examples where they provide it as a platform as a service. Now, everything we are going to keep it in the cloud, right? For various tasks, there are many applications where now you don't have to keep anything at all in your site. What you need is only the internet connectivity and a browser where everything will be online and it can be accessible from anywhere. So we have a lot more flexibility in that day. With the nominal fee, you can handle everything. And when you need it, right? Because sometimes the software, we might not need it throughout the year, right? So going for software as a service method will be more profitable in some cases. Now, just to give you some examples in this, in software as a service category, there are many applications now it's available online. Now, for example, if you think about the user productivity, uh, uh, so we can think of Microsoft Office. For example, we have 365, Google Workspace, and Adobe Creative Cloud. So these are like for individual productivity tools. And if you're thinking about the team productivity, team collaboration, and also managing work among the team, there are tools. There are popular tools. Some is Trello, Jira, Confluence, ClickUp. So these are some of the examples. And for the communication, uh, we already notice software like Zoom is available, Slack is available, and even you can have workflows, for example, Zapier. Similarly, there are some specialized piece of software like website. We have Wix, Squarespace, e-commerce solutions, for example, Shopify, WooCommerce, BigCommerce, and then handling customer relations, customer relation management, Salesforce, Zendesk, HubSpot. And then in enterprise level, we can, for finance, we have SAP and Oracle. HR, we have Workday. Procurement, we have Ariba. Then we have supply chain, Atlas planning, admin, DocuSign. So for example, the DocuSign is commonly used when you want to make a digital signature. So they can actually manage within the software, right? So as you can see, so we have a huge um, software as a solution, software as a service solutions available. Now, according to the Crunchbase, there are over 23,000 software as a service, companies there, right? This is just a number, but the updated one will be much higher, right? Now, if you look at SaaS, the idea, so it's about centralized computing and entire business processes, entire business, uh, employees who works for the organization that can actually use online products, right? Mostly these are rented products. So everything will be done on the internet, right? And as I told you earlier, what you need is a browser and also the internet connectivity, right? So for example, Microsoft 365, Google Apps, these are some examples where majority of users are using. Right, now let's briefly discuss the web-based development versus traditional methods. Traditional systems usually works with various hardware components, software environments, and also we have to compatible with the legacy system. For example, the commercial world, early days, many of the systems were developed using COBOL, which is uh, legacy programming language, but still some places you will see they have developed their legacy system using COBOL, which is very rarely we use today. But there's a huge demand. Sometimes still some enterprises prefer to use their legacy systems. But if you look at how internet-based systems, usually they use the web as their platform, and many companies use the web-based system. So as you have already seen, there are like many applications where you can have enterprise-wide solutions. And on the other hand, when you compare our traditional system, we have some difficulty when you want to scalable, like when the numbers are growing, especially if you have physical hardware and everything, it's very difficult to scale. But if it is a cloud-based solution, then easily you can scale. You can increase the number of users who can use your system, right? So that's one of the advantage uh, we will get when we use cloud-based software solutions. And then it's also adaptable to outsourcing operation. So because nowadays, most of the organization, they outsource their work. You might have seen some organizations, they outsource because then it minimize and they can focus on their core business. So there are other benefits as well if you use a web-based system, as well as sometimes there'll be a risk as well uh, if you compare with the traditional development. Okay, if you look at the traditional system development environment, so the design will be based on the compatibility of the existing hardware software platforms. And also like sometimes if you have any legacy system, you have to think on those as well. And then usually the systems are designed to run in local or wide area networks. It uses internet, but commonly you are not going to use web-based features as, but you may have it as the enhancement, right? So there are three main parts in traditional development. So you can go for in-house development, which means if you have a dedicated IT team, and also you have the required expertise, then we can go for in-house development. Second, you can go for purchasing the software, right? And especially when you're purchasing, there will not be any software which suits to 100% to your requirements. So you should make some modifications, and then you might actually use some outsiders. But remember, scalability might be an issue because this is affected with the limitations of the network, and you need a lot of computing power as well as resources. But the advantage you might get following this is you have very less issues with the security. So usually your system is runs on the private network and it's not in the internet. So which means you have a less security issues. If you focus more detail on web-based development, now you might use internet-based frameworks, .NET or WebSphere, or you can use Google App Engine or AWS Lambda. So that means you use some framework. And then you can also use this as a web as a platform. And then they can easily be scalable, and also it can be run on multiple hardware environments. So large firms, usually they deploy the web-based systems in enterprise-wide software solutions for things like customer relation management, order processing, and materials management. Further, you can see web-based software treats software application as a service, and it's less dependent on what hardware you in the premise, meaning like desktop computing and the other resources. And then when companies acquire the web-based software as a service, they can limit the in-house involvement. So the cost is less and it's easier because you don't have a burden to maintain the software. And then vendor can install, configure, and maintain the system. The idea is whenever you have an issue, you can ask a vendor to come and do the changes, which is actually less burden. You can, as I told you earlier, you can focus on your core business. But then you usually some additional layers. We call it middleware, which is you need the middleware to communicate with existing and any legacy systems. Right. Now, let's look at how the web is evolved and the facilities got. Now, starting from Web 2.0, you will see we have a second generation of the web, we call it. And there we see people collaborate, interact, and share information. And based on the continuously available use applications, we can we do not have any limitations or how they access or modify and exchange data. The web 2.0, 2.0, it enhanced the interactive experiences, and people have wikis and blogs compared to early days where we have very static web pages. And you have social networking platforms where we can the people can freely express their ideas. Now, with the web 2.0, we also notice the cloud computing, and some say cloud computing provide overall online software and data environment, and which is backed by the supercomputer technology, right? So what we can notice is with the software as a solution, the services and the data. So you just need internet connectivity and browser. Just to a simple comparison between the web 1.0, 2.0, and 3.0. Our early days, we had basic pages, HTML, e-commerce, Java, and JavaScript. But the web 2.0, we have social media and user able to generate their own content, mobile access. You have high quality camera and video, apps. Corporations can monetize your data, high-speed communication, global internet access. But what we expect in the future, right? We have semantic webs. We have DApps, users monetizing their data, NFTs, VR, AR, we call metaverse, permissionless blockchains, artificial intelligence, interoperability. So this is what we expect in Web 3.0. So outsourcing is another option you have, and we have discussed this in last session as well, which is basically you are going to maintain, or you are going to have somebody else for a temporary or long-term basis to work on the information system, right? There will be some application providers, and then they offer internet business services, we call in short IBS. More details on the application service providers, the firms, they deliver software application, access to the application, and usually you have to pay some subscription fee, right? So many of the applications sometimes give you some trial time in the beginning so that you can try out, and after that you have to make some payments, so annually or as a monthly fee, right? So if you use application service providers to supply, for example, data management package, and company does not have to design, develop, or implement or maintain the packages, right? So this is actually a trend nowadays as a primary delivery channel. Some firms, they offer internet business services which provide powerful web support for transactions such as order processing, billing, and then customer relationship management. And this solution is attractive because they offers online data center support, mainframe computer power, and mission critical functions, and universal access via internet. Nowadays, you have a trend where now this support that you are getting from the outside, even it's not in your country. it is outside um, the country. So offshore outsourcing or global outsourcing means we use the IT development, support, and operation in other countries. Now, for example, in Pearson, I hope you might have already heard about the Pearson education platform. All the IT uh, development happens in Sri Lanka, whereas their core business is in US and Canada, while all the IT operations they have put it into Sri Lanka. So, for example, Pearson Sri Lanka is the one actually who handles all the IT operations within Sri Lanka. So, you can notice this as a trend. Most of the developed countries nowadays, they are putting the IT related work to countries like ours or India. So this is what we call offshore outsourcing. The other option is we have already discussed in detail, that is in-house software development. So we can see a company can develop its own system or purchase, or you can customize to implement. There are many factors, but what you need to think about is when you are actually develop or you are going to outsource, you have to think about the total cost of ownership. Now, when I use the term total cost of ownership, what it means, it's not only the money that you spend on developing or purchasing, but throughout the use of the software. Remember, although you spend some money in the beginning, later on you need more money to maintain as well. So everything together we normally call uh, total cost of ownership. So in-house development, as you already seen, when you are developing, it could be in-house, it could be like outsourced. But the problem is you have to think about all the possible costs involved in the software. It's not only software development. There'll be a cost for software maintenance as well. So you have to consider everything, right? So usually in first couple of months while the development, it will be a high cost. But after that, annually, you have to spend some time, some amount of money for maintenance, right? So everything together, we normally call total cost of ownership. Right. So make or buy decision is often we have to make. So for example, once during our cycle, we started our information system by planning and analyzing, and then uh, we have to make the decision whether we are going to make or whether we are going to purchase. So if you are going to make and build, it will be an in-house. If you're going to purchase, it will be a commercial software package. But ideally, what will happen usually, we purchase a commercial software package and we customize it, which you will see here in the middle, right? And then after that, you are going to implement. Now, for example, even at SLTC, right now, what we are looking at is we are going to looking for a fresh software solution, but then we are basically in an agreement to customize to suit our requirement. Because when you purchase, usually, if it is not very general application, it will not fit 100% to your organization, right? So some comparisons of why we have to do in-house and why we have to purchase a software package. Um, Especially in-house development will satisfy our unique business requirements. Even though, let's say there are some software for managing higher education institutes, but not all institutes work the same way. For example, we have our unique way of delivering content. We have mentoring, we have interactive. Sometimes you might not see this kind of delivery in other places. And then we can minimize the changes. For example, we already have some procedures and policies within an organization. So if you are developing your own software, you don't have to change anything. But if you're purchasing software from somewhere else, then maybe we have to change some procedures, the way of doing things, because then to suit for the software and meet constraints of existing systems, meet constraints of existing technology, because the problem will be when you have existing system. So for example, although we are going to purchase a software for SLTC, we already have finance systems which works fine. So maybe we don't want to change that. What we need is when you purchase the other items, we want to compatible with what is existing. Similarly, it should also compatible with what is existing technology. And sometimes we want to develop our own resources and capabilities, because if in the long run, any organization wants to have their own IT department where they have specialized with this software development in their particular chosen area. And also especially for the security, because you know what is going on inside in your software, whereas when you purchase from somebody else, maybe you are really not aware what is going inside. Okay, then let's look at reason for purchasing a software package. Lower cost, of course. When you're developing in-house, it's a huge cost that you have to bear. Whereas getting a software or purchasing a software will be much more easy. And when you're purchasing it, you need very less amount of time to implement, whereas development might take years. Third one is, okay, if you're purchasing some software, you can actually look for other customers who have already using their system. So you have some reliability and performance. So you can check with already existing customer base. And then you need less technical development staff. So for example, if we have our own software, we have to have a development staff, which costs a lot to the organization. But then if you are choosing or purchasing, then you need only very less technical development staff. And the upgrades provided by the vendor. And then you can also get the input from the other companies, which I have already discussed. So next, particularly, we'll focus on customizing a software package. Now, if the standard version of the software does not satisfy our requirements, then you can adapt the existing software, right? So there are three ways we can talk about. The first one, we can purchase basic package. And then the vendor can customize to suit our needs. And then second option is you can talk to the software vendor directly and then make enhancement to meet your needs. But of course, you have to pay some extra charge for that. Or else you can purchase the package and you can change by yourself. So this is another interesting point. You can purchase and you can make your own modification. Right. Now that we talk a lot about costs, right? Let's have a small discussion on the cost and the benefits. So I told you, like, when you're making a decision on the development strategy, you can think of the total cost of ownership. Now, total cost of ownership meaning direct costs, the acquisition cost, which means you are going to develop or you are going to purchase. And then the indirect expenses, which means ongoing support and maintenance costs. So both together, we can call it as a total cost of ownership. So this is very, very important. If you're looking for several alternatives, let's say you have some alternative choices and you have to select one of them. So we need to identify what are the alternative, what are the cost involved, right? So for example, there are costs called indirect costs, which not always apparent. And then later on, you figure it out, it's most costly choice. So therefore, when you're identifying the cost, total cost of ownership is very crucial. Remember, mostly 80% of the total cost comes after purchasing the hardware software, according to Gartner, which is why we have to be very careful. It's not just the initial cost that we have to look, but the cost incur after purchase or development. The next parts actually we have already done, but we need those for this subject as well. So I quickly review. I'm not going to spend on this like we did in our previous case, but very briefly, I will go through these different financial analysis tools. Right. So our previous discussion also, we discussed three financial tools where we want to make a decisions based on the financially. When you select which product we are going to, select. So payback analysis determines how long it will take to system to pay itself, right? Which means usually there'll be a cost in the beginning, then you get some benefits. How many years, for example, will take to cover the costs with the benefits? So that's what we call payback analysis. The next, we have return on investment, ROI, which says we have project total return with or the total cost, which we call ROI, or which means return on investment. Then we have net present value, NPV. What it means, we know over the years. That means we are getting benefit this year, next year, and after that, what you calculate to future can be taken into today's costs and benefits. And we can make a decision. Right. So in cost benefit analysis checklist, usually we have to list each development strategy, whether you are going to develop, whether you are going to buy or customize. And you have to identify all costs and benefits, right? And then you have to think what will happen in the future as well. You have to include support costs and various licensing options. So for example, some places you can actually make license for per month, annually, you know. So you can check on various options you have. And then you use financial analysis tools, and then you study the outcome of this, and then you report to the management. Right. Let's look at software acquisition process. So when you're acquiring a software, you have a series of steps. You have to evaluate the system requirements. You have to consider the network and web-related issues. Then potential software vendors or outsourcing options. You evaluate the alternatives and then perform cost-benefit analysis, and you prepare the recommendation, and then you are going for the implementation. So when you want to acquisition, you can use request for proposal or request for quotation. I think we discussed these ideas in the last session as well. So which we can use them for vendors to respond with the features. If you look at the transition to system design, the system requirement document, which is the outcome, and then that will be the end of the system analysis phase. And you have all the requirements, constraints, and the recommendations. And also it should provide the cost and time estimated for the development work, right? So this will be present to the management, and firm then is going to decide whether are we going to develop in-house, or whether we are going to modify existing, whether you are going to purchase some software package. So costs can be classified in several ways. So for example, cost can be classified as tangible or intangible, direct, indirect, fixed and variable, and development or operational. So the tangible costs are costs for which you can assign for a specific dollar value. For example, employee salaries, hardware, software purchase, and office supplies, such as like papers. And then we have intangible costs. You cannot put any monetary value or dollar amount. So for example, customer dissatisfaction, lower employee morale, reduce information availability. So it's very difficult to put a cost for this. Then we have direct and indirect costs. So direct costs, the cost, directly related to the development of the system. For example, salaries of the project members, purchase of hardware. But if you take indirect costs, we cannot attribute to development of the system. For example, salaries of network administrators, it will not be direct one. And other copy machine rentals, insurance expenses, they are called indirect costs. Then we have fixed costs and the variable costs. Fixed cost means they are constant, and then It happens usually regularly. Again, salaries, hardware rental, and so on. Then variable costs depend on the level of the activity. So, for example, cost for printing paper, telephone line charges, they are called variable costs because that depends on how many minutes that you have consumed. Then we have development costs and we have operational costs. So development means when you develop in the system, right? Operational means after you implement the system and when you continue with the system. So for example, system maintenance and the training, annual software licensing, they are comes under operational costs. Although we discussed a couple of ways of separating costs like this, remember many belongs to other categories as well, right? So if you take overtime pay, you can use it as a development, right? And then you can say it's a variable and direct costs. Similarly, if you take monthly fee, right, you can think it as an operational cost, fixed cost, and indirect cost. So likewise, you can apply more than one category for expenses. Now let's look at the benefits. Benefits again can be tangible and intangible. Tangible meaning like it's obvious, but some are like many you can give some dollar amount, dollar value, but in intangible you cannot give, right? So the benefits also we specify that tangible, intangible, fixed or variable or direct or indirect, right? And then we can also classify it based on the nature of the benefits. So let's look at some benefits in detail. Positive benefits. We have increased revenues, improved services. They contribute to organization direct result of the information system. So we can say they are positive benefits. Example, improved information availability, greater flexibility, faster service to customers, high employee morale, and better inventory management. Then we have cost avoidance benefits. Okay. For example, refer the expenses that would be necessary if the new system is not installed, handling the work with the current staff instead of hiring additional people, not having to replace hardware and software, and avoiding problems that otherwise would be faced with the current system. Okay, now that we have discussed a couple of cost items, now we can discuss in detail the cost benefit analysis. Under that, we are going to discuss 3: payback, return on investment, and present value. So if you want to do the payback, how long it will take to cover the initial costs is what we do within payback analysis. And for this, we have the time it takes to recover the costs. Usually, we call the payback period. So the several steps, you can first start the initial development costs, and then you can estimate annual benefits. You can find annual operating costs. And once you compare the total development and operating cost with the accumulated value to the benefits provided by the system, you can find the payback analysis. Let me explain a little bit more detail. Now, if you look at the costs in developing a software, would be something like this. So you can see in x-axis we have time, y-axis is the cost. So when you're developing the system, it incur higher costs. So you see very high. But then once you implement this, system is in operations mode, it's declining. Economically, we can useful, right? So this is where we have that economically useful life. The benefits, on the other hand, so when you develop the system, we will not be able to get any benefits. Agree? So you can see the curve going right towards the right, and it's cumulatively improving. So you can see when you start operating, ideally what we expect is our benefits will grow. So now if you put the two curves in one single figure, it looks like this. This is what we have costs, and this is the benefits. If you take what is inside, right? So in that particular case, you can see here what is inside. That means this part. These are the cost items. And then we have so the areas that we have drawn in blue and red, you can see the area should be matched. So when the area should be matched, we say it's the payback period, right? So you have to calculate both, and then you can find the payback period. Right. If you continue, we have to accumulate cost and benefits, and then we can find a place where both the costs, right, is available. So for example, here you can get two projects and the cost and the benefits. So idea that we are trying to follow it here is just to determine whether which project is more desirable, meaning that you have a less payback period. Okay, now let's try to understand what is in the table. So we have project A. Initially, you will see the cost is 60,000. That means after start, especially system development, you have to spend some money. So initially, it will be a huge amount, but gradually you can see the numbers are declining. But still, you have to pay some money, right? So which added to cumulative cost like this. Then the benefits. Once the system in place, then you are going to have some benefits, and you have to put them in a number so that you can compare. So benefits, you can see the first year we have 3,000, second year 28,000, and so on, which is what we see here. And when you get right, the cumulative benefits you will see in another column, and then communicative cost is another column, which you can use to decide using both the cost and the benefit, we can decide on the payback analysis period. Similarly, project B also, you can see the similar kind of pattern. Quick question. So how long it will take for project B to pay back? Can you give me the answer in the chat? Since I'm not getting an answer, I'm wondering whether you already know the answer or not. So you better answer, otherwise I might have to repeat. Yes, how many years do you think it will take to get the payback period? So after 3 years, the cumulative cost is 114,000. And then we have benefits is 96,000. Yes, by 4 years, we have 135, 132. Definitely between 4 and 5 years. Good, Tarindo. Yes, after 4 years, 4 and some. Exactly. So project B, similarly, if you look at cumulative costs, so you can see here we have 167, the costs 86, 191, we have 156. Again, between 4 and 5 years, we get the cost meets the benefits, right? So what it means, the payback period will be between 4 and 5 years. We have done small exercise in Excel as well, and we have seen this is between 4 and 5 years. This is just after 4 years, the project A. Project B will be little more than 4.5 years. Right. That's the first financial analysis tool. The problem with the previous one is actually we are not considering any of as a ratio. We just use the amounts. Whereas return on investment analysis, we see this as we compare the total benefits and total cost, and we take a ratio of total costs. So for example, here, can you tell me what is the ROI for A? Right? Total benefits, total cost, total cost. We have total benefit, total cost, and you divide by total cost. So you can get it as a percentage if you want. So this is the equation. So using this equation, can you tell me what is the ROI for project A and what was the ROI for project B? So to find the ROI, we have to get the cumulative benefits, that is 213,000, subtract the costs 181,000, divide by 181,000 and multiply by 100, you will get 17.7. That is the ROI for project A. Similarly, for project B, we have 330,000, subtract 240,500, divide by 247,500, which is about 33%. So you can see, if you look at the numbers, ROI for project B is high. But actual comparison comes like this, right? So usually we say about only a minimum ROI. So for A, it's 17.7. For B, it's 33.3. So let's say what we need is ROI 15%, that we specify the minimum ROI we need. So according to that, both project A and project B is beneficial, isn't it? Because both actually can be used. So we can say that project B is better than A, but still, if you say ROI 15, both A and B is meeting the criteria we define there. Right. Let's move to the next one. Now, this ROI, right, basically calculates the total rate of return. But remember that depend on the time. The timings are different. The benefits we get in the first year is very minimal, then the second year, third year, fourth year, and so on. So what if you think about the timing as well? Because ROI will not consider the timing of the cost and benefits. So what happens? It ignores just the cost and the benefits. So we use our last one, present value analysis, right? So present value analysis can be used to find what will be the future cost for today's terms, and we see are we getting a profit when compared to the when you perform the analysis. So to perform present value analysis, we need something called present value tables, which means by getting the values, what will happen, right? Now this is table is for, let's say, $1. How much you have to invest to get $1 at the end? Now, for example, let's say these are like years. In that particular case, if with the 6% interest, if you have 0.943 after 1 year, you will get $1. Similarly, if you have 0.558 with 6% accuracy, you will get $1. So it's like that. So when the interest is higher, you can see, for example, here, if the rate is 14%, so during the first, we have, right, to earn $1, you have to have 0.877. Whereas if you have right now 0.270, you will get, here we have one, right? $1. You have to have 0.270 with the 14% interest. That's how we talk about net present values. So let's look at the same example we discussed earlier. Find the present value of $1 at 12% for 5 years. 12% for 5 years, 0.567. Right? And then if you want to find out the present value of $3,000, this is for $1 we have done. So you have to simply multiply by 3,000 and you will get the answer. That present value. So when you're working with the net present value with the project, you have to adjust the cost and benefits according to this to the present state. And then when you can calculate what we call net present value. So the total present values of the benefits money minus total present value of costs, which we get the net present value. Right. Can you quickly perform the NPV analysis?